Alright guys, welcome to this page of the notes, and what we're going to see here is the next possibility when it comes to the quadratic formula. You plug all that stuff in, and what happens is you wind up with a b squared minus 4ac, which comes out to be a positive number that is not, right? Not a perfect square. And what will happen then is you're going to wind up with an equation that has two irrational roots. Now remember, we've seen this idea of getting irrational solutions before, and what I prefer to do is just leave them in radical form, right? You're going to wind up with the square root of a number that's not a perfect square, which means it's irrational. Please don't give me decimals, right? We'll just leave it in radical form, and you'll see exactly what I mean when we try an example. So here we go. This one is already in standard form, right? It's got the, that's my highlighter. There we go. It has the ax squared plus bx plus c is equal to 0, where a is equal to 2, b is equal to 6, and c is equal to a negative 7. Let's plug and chug, guys. Here we go. Oh, careful. 2 times a, and my a is a 2, so it'd be 2 times 2, which is 4. Plus or minus 6 squared minus 4 times a times c, all over, once again, I get 4. All right, here we go. I can reduce this, pull a 2 out of both, and I wind up with negative 3/2. Plus or minus. 6 squared is 36. And negative 4, let's see, a negative 4 times 2 times a negative 7 is going to be plus 56. All right, and 36 plus 56 comes out to be 92. So I have the square root of 92 over 4. Like we said, 92 is not a perfect square. So what I'm hoping is that there are two factors of 92 where one of them is a perfect square, and I believe 4 and 23 will work. Awesome. Well, the square root of 4 is 2 times the square root of 23 all over 4, and I can reduce that fraction. 2 divided by 4 is a half. All right, now, here's where I'm at. I have the square root of 23, which is not a perfect square, and I can't split it up into factors that are perfect squares. So it's done, and it's an irrational number, so I'm going to leave it as a radical. And so I have my two solutions. X is equal to a negative 3/2 plus the square root of 23 over 2. And x is equal to negative 3/2 minus the square root of 23 divided by 2. And both of those are irrational solutions. Why are they irrational? Well, because you're taking the square root of a non-perfect square. The square root of 23 would be an irrational number. So we wind up with two irrational solutions. Let's try another one. Okay, this one looks like fun. It's already in standard form, so let's go ahead and show you. Ax squared plus bx plus c is equal to 0, where a is 3, b is 5, and c is 1. And you guessed it, it's plug and chug. Minus 5 over 2 times a. My a is a 3, so that'd be 6. Plus or minus, it's going to be a 5 squared minus 4 times 3 times 1, square root, and all over 6, which means x is equal to negative 5, 6, plus or minus 25 minus 12, all over 6, which means x is equal to negative 6, plus or minus 25 minus 12 would be 13. And 13 is not a perfect square, and it doesn't have any factors that are perfect squares. So it turns out I'm done. I have two solutions, both of which are irrational. Negative 5/6 plus the square root of 13 over 6, and it's irrational because the square root of 13 is an irrational number. And my other solution is negative 5/6 minus the square root of 13 divided by 6, which is also going to be irrational. Here's another one. I got to put this one in standard form, so let's do that first. X squared minus 8x, add the 9 to the other side. And we got it in standard form. Ax squared plus bx plus c is equal to 0, where a is 1, b is a negative 8, c is 9. Yep, you guessed it. Plug and chug. Minus a minus 8, all divided by 2, plus or minus a negative 8 squared, minus 4 times 1 times 9, all over 2. Let's see what happens with this one. X is equal to, negative times a negative would be a positive 8. 8 divided by 2 would be 4. So 4 plus or minus. Okay, negative 8 squared is going to be a positive 64. So I have 64. And a negative 4 times 9 would be a minus 36. All right, so here's what happens. 64 minus 36 gets you 28. Now, 28 is not a perfect square, but that's okay. I can think of two numbers that multiply to 28, and one of them is a perfect square. Turns out to be a 4 and a 7. Slide up a little bit so you can see. And we take the square root of 4, which is 2. So we wind up with x is equal to 4 plus or minus 2 square roots of 7, all divided by 2. That's right. Those 2's cancel each other out. And you are just simply left with 4 plus or minus the square root of 7, where I have two irrational solutions. Why are they irrational? Well, because 7 is not a perfect square. You take the square root of 7 and you're going to get an irrational number. So 4 plus the square root of 7 and 4 minus the square root of 7, two irrational roots. Guys, that takes care of the problems on this page of the notes. Head on over to the next page of the notes and we'll take a look at another possibility when it comes to quadratic formula. So I'll meet you over there.